Today we'll talk about generic functions, just as we did last time, but now we'll focus on the case when there are multiple generic arguments. So recall that generic functions come into play because a function might want to operate on multiple different types of data. And last time, we saw that we could achieve that by writing down polymorphic functions using message passing. So we had this idea of interfaces, which are collections of messages, which are just attribute values in the object system, for instance, and these have specific behavior conditions. So the stir message is meant to give us back a human-readable string, for instance. And we saw that with this idea, we could create two different interchangeable implementations of complex numbers. And the reason why we had two different ones is that they were each useful for a different kind of combination operation. It was easiest to express addition using a representation that gave the real and imaginary components of a complex number, and it was easiest to define multiplication using a polar representation with a magnitude and angle. Okay, so what about today? Well, we're going to keep extending our idea of different types of numeric representations. We're going to build an arithmetic system over related types. We're going to build an arithmetic system over related types of numbers. We'll introduce the idea of dispatching on type and also data-directed programming. Finally, we'll talk about type coercion. So these are all just different ways of implementing generic functions, functions that operate on multiple data types. So I'm just giving you a grab bag of useful approaches because there's no one right way to do it. So what's different about today from last time? Well, today's generic functions are going to apply to multiple different arguments. So we're going to think about functions that take multiple inputs, and those inputs don't necessarily share a common interface. What do we do? Well, we could use these other techniques instead.